So this question starts with log base 3 of 2x minus 1 equals 4. So let's remind ourselves of what this means. The base is 3. The exponent is 4. So 3 to the 4th power equals 2x minus 1. Three to the 4th power is 81. Equals 2x minus 1, add 1 to both sides. 82 equals 2x. Divide by 2, 41 equals x. Now, is there a way for me to check that? I think so. Let's go and look at Desmos, if we can. So I'm going to graph both of these things on Desmos. So log base 3 of 2x minus 1 log, shift underline, log base 3, parentheses, of 2x minus 1. Where does that equal 4? So y equals that, y equals that. When are they the same? Well, we think the answer is 41, so we better take a look around 41. Do they crisscross at 41? It kind of looks that way. We don't have a whole lot of resolution here, but sure enough, 41, 4. I can highlight that point to see that that's where it is. So that's one way to sort of do it. Take a look at our next question. We have log base x of 81 that equals 2. Log base x of 81 equals 2. How do we do this? Again, we have our base and our exponent. Our base is x, our exponent is 2. So x to the 2nd power equals 81. X to the 2nd power equals 81. Let's take the square root of both sides. So square root of x squared is square root of 81 plus or minus square root of 81. So x is plus or minus 9, except the base of the log has to be a positive number. So my only answer here that I can work with is 9. Now, how do I want to check this one? This time I think I'm going to jump to the graphing calculator and check it the following way. Log base x of 81 is 2. Log base x of 81 minus 2 is 0. I don't really have a way to graph easily log base x of 81, so I'm going to use the change of base theorem and realize that's natural log of 81 over natural log of x minus 2 equals 0. I'm going to try to find out what the x is. I hope it's going to be x equals 9. So let's jump to the graphing calculator, and I'm going to graph y equals this, log 81 over log x minus 2. To check our work on this one. So to the y equals button, parentheses, natural log of 81. Watch your order of operations, it gets tricky, divided by natural log of x. We said minus 2, we want that to equal 0. Minus 2, where does it equal 0? We think it's going to happen at 9. So let me go to zoom standard and see if it looks like it's happening at 9. Oops, looks like I didn't hit zoom standard. So I'll try that again. Zoom standard is 6. My problem is I think it's going to really sit pretty close, and it's kind of difficult to see what's happening out here near 9. So I'm going to adjust my window one more time, and I'm going to go with my y min of, oops, went too far. Y min of -2. The negative button is here. And the y max, I'll go to +2. And we'll try graph again. And like I said, I think it's going to cross at 9. I hope it's going to cross at 9. And notice it's not crossing at -9. To find that point of intersection, let's go to the zero finder, second calc. Zero finder is 2. Move the man in the spaceship a little bit to the left of where it crisscrosses. It'll take a while to get there. There we go. So pretty close to 9, but a little bit to the left. That's pretty good. A little bit to the right of where it crosses. And then guessing it, right there is a decent guess. And sure enough, x is 9. That's my only answer. Notice -9, not a solution. The base of a log has to be a positive number. Okay, I've got one more question to do here. Log base 5 of x plus 3 equals -2. So let's solve it algebraically first, then we'll check it with technology. The base is 5, the exponent is -2. 5 to the -2 equals x plus 3. 5 to the -2, 1/25, or 1/5 squared, we'll say that first. 1/5 squared is 1/25. Then subtract 3 from both sides. 1/25 minus 3, which a good job for a calculator. Maybe I should show you how to do that on a calculator. (1/25) minus 3 gives me a decimal, and go to math, change to a fraction. That's the first one, enter, enter. And I get -74/25. So that's what we believe the answer is, okay? We believe the answer to that is -74/25. I can also check this on the calculator as well. I'm going to add 2 to both sides first. Log base 5 of x plus 3 plus 2 is 0. Again, I can't do log base 5 of x plus 3 easily on the calculator. So I redo it as natural log of x plus 3 over natural log of 5. Plus 2 is 0. We're going to graph this and find out when it's 0. And I think it's around -74/25. Pretty darn close to -3. So let's do that. And what do we have? We have natural log x plus 3. So I'll save myself some work here. I'm just going to type over what I had before. So I have x, insert button enables me to add stuff in there. X plus 3 over natural log 5. Oops. And then it's supposed to be plus 2 instead of -2. And I want to see when that's 0, and I think it's around -3, so zoom decimal's pretty good. That's 4. And we made it to adjust the y. What's happening? We need to be a whole lot closer. So I think I need to zoom in on this. I'm going to get pretty close to -3 because the graph's not quite hitting where I need it to hit. So we'll try this to see if we can get a way to check our work. There we go. So this point where it crosses is my answer. So can I find out what that is? Second calc, 0 finder. Left bound, I have to go to the left of where it's crisscrossing, which here's the only point I have to the left is here. Point I have to the right is here. And I'll use that also as the guess. And I get -2.96. Now remember, what was -2.96? -2.96 was -74/25. So that checks our answer. And sure enough, the answer to log base 5 of x plus 3 equals -2 is -74/25.